Hello everyone and welcome to this video. I will be walking you through my machine learning project titled PaisaBazaar Credit Score Classification Model, where we predict a person's credit score category using real-world financial attributes. So this is the GitHub link, and coming to the project, this project simulates a real use case from the Fintech domain where classifying credit scores as poor, standard, or good is crucial for credit lending and loan purposes and approvals. We will go through the entire pipeline from data exploration and cleaning to model training, tuning, and evaluation to build an efficient credit score classifier. So these are the libraries which we input. We will be using mainly LGBM, light BGBM models and simple models like XG, XGBoost, etc. And we use random forest classifier also. And coming to the data set overview, by loading the data set, shaping it, taking the info from it. So here the data set contains around 100,000 rows and multiple features such as annual income, monthly in-hand salary, number of credit cards, number of delayed payments, credit history, age, occupation, types of residence, and more. Our target variable is credit score, which includes three categories such as poor, standard, and good. Initial checks reveal some missing values and imbalances in target classes, which we addressed in pre-processing of this dataset stage, like taking the columns describing unique values. In this feature engineering, credit card mapping, here counting the debt to income ratio, credit card utilization score, credit card mix score, payment delay score. These are the data manipulations. What of the insights found? Better data quality, impact like debt to impact income ratio, credit utilization and risk. In this, now in data processing involves several key steps like label coding, missing values, categorical features like occupation and types of residence. And we also apply standard scaling. So in data visualization, we use some charts. In this first chart, the distribution of the credit scores, that is standard, poor, good, according to the count is taken. Here we can see why we picked this chart because of distribution, and the gain insights are that lead to negative growth. No. Distribution of age. Here the 20 to 40 age is more frequency than other ages. And coming to annual income distribution, averagely 25,000 is more frequent. More people has 25,000 nearly annual income as annual income through this chart. And next coming to credit utilization ratio distribution. it is over from 20 to 40. Portion of the customers exhibit a high credit utilization in this age, like a credit utilization ratio. As number of credit cards distribution. The frequency is from 4 to 8. Annual income versus credit score plot. And so here we are plotting the target balance like good, standard, poor. The count is greater for standard, poor condition, and then lastly good. These are the features graphs like month, age, annual income, etc. These are the features extracted from this columns. And for these features, we have plot the correlation heat map. These are the colors for the high intensity, low intensity. Correlation between two different features. I'm coming to pre-processing of this pipeline. We extract the features like numerical and categorical features and using the column transformer in pre-process. We used label encoder for target column, converting poor, standard, and good to numeric form, and missing values like monthly enhanced salary were filled, and categorical features like occupation and type of residence is used were handled by using one hot encoder. Lastly, in pre-processing in model, the training and test data sets is 80 to 20 ratio. It's taken 80 to 20 ratio. Here in hyperparameter tuning, we used light GBM model and also a randomized search CV because 100,000 records are dataset is more. So I have taken randomized search CV of 10 combinations with 3 folds. Like so 3 folds into 10 totaling 30 fits. The best this gave the best score of 0.67. So in this model selection I have taken random forest XGBoost and light GBM, but in after initial experiments light GBM consistently perform the best in the terms of F1 score. Like in this F1 score, especially after tuning, we got 91%. In hyperparameter tuning, we have taken the randomized search CV instead of grid search. It is almost similar when using by GPU. If we take a grid search, we can use GPU for runtime type. Then it is almost similar to 92%. But according to mine, I have taken randomized search for less time, less runtime. So in the model evaluation, we have got confusion matrix like this, good, poor, standard, correlation here to visualize the misclassifications. Classification report here for president, we have taken F1 scores per class. This here to 0.014 are similar to 91 or 92%. This means it performs well across all classes, not just a majority class. Here the metrics are confusion matrix to visualize and classification report for precision, recall, and F1 scores per class here, and ROC AUC curves to compare model confidence levels. Our model maintain a good balance between precision and recall, especially important in financial classification tasks. So here in business impact, speed up this model can be used in to speed up credit assessments, automate risk profiling, and improve loan approval decisions, and reduce the chances of default or fraud cases. To conclude, we processed and explored real-world financial data from PaisaBazaar and trained and tuned several models, and finally achieved high accuracy of 91% using light GBM. For next steps, we can deploy the model in API. Here we used Joblib. That's it. Thank you. This is the final model which I have taken for PaisaBazaar credit score classification.